Okay, so welcome to our second virtual meeting of this school year, guys. Okay, my dog just decided to bark as soon as I joined. Alright, so in today's meeting, we're actually going to be, so it's a short recap of last meeting. So we installed a Java IDE and took a Java beginner quiz, and we went over all the basics of Java, including topics such as data types, math functions, if statements, loops, arrays, running Java, and getting user input. And now today we will be starting our first ever Java project for the coding club this year. And we will be applying what we learned last week to make a calculator in Java. Just make sure that you have Java in an IDE installed and open, or an online Java compiler before we begin. I will be using the Eclipse IDE for today and the rest of our unit for my IDE. Alright, let me share my screen so you guys can see what I'm doing. Okay, so...
Yeah, I'll stop sharing my screen.
Alright, just first, let's everybody... Can all of you guys see my screen?
Yeah, we can.
Okay, so first of all, what you're going to do is you're going to want to right click in Package Explorer, go to New, Java Project, let that load up, project name, Calculator. And you really just do not want to create a module info.java file at the bottom. You just never want to do that. That always messes with your programs. So once that's done, you're going to right click on source, new class, and also name that calculator. Now it should open up as this. So has everybody gone to this point? I'm gonna take that as a yes. So now what we're gonna do is that we're gonna create our main method and initialize some of the variables that we will be using. So we're gonna create our main method. Just tell me if you want. Just tell me if you want me to slow down. Then. So now we're going to want the user to input two numbers, num1 and num2. And we're also going to want them to input whatever operation they want us to perform, addition, subtraction, multiplication, division, and exponents later. So that will be stored in operator. And then we're going to need to actually enter the prompts in. So you're going to do scanner, scan, object, new scanner, system.in, and now as you can see here, it's showing us an error because it doesn't know what a scanner is, because that's not in the basic Java thing. So what you're going to do is type out import java.util.this. That should resolve this. And then you're just going to print out your basic prompts. So please enter your first number. And the system.out.println. What operation should I use? NM, can you please mute the mic? Thanks. Okay, so as I was saying, yeah, that should be it.
Oh, really?
Yeah.
I don't think you put next. I don't think you put int after next.
Alright. Smart. Thanks.
Yeah.
Alright, so these will be our prompts. So once you run the program, the program will ask you to enter your first number. After you finish that, then enter your second number, ask you for your operation, and then it should do it, but we're not done yet because we actually have to make a code. This stuff. First, we need to initialize our answer variable. We're going to be using a double because that will make it easier, especially for division and all that stuff. So then, Joseph, do you want to do the switch statements part?
Sure. Okay. So make sure my
I'll stop
you
sharing
guys
my screen.
can you guys see my screen? Share me, see my screen, anything?
Let's see here. It's taking a while to load.
That's loading. Okay. Yeah, I might. I'll go and try it again. Okay. So I can see it. So can you guys see my screen now?
Yeah, now I can see it.
So as of right now, we have this right here. We have the numbers. We have the integers declared, and then we have the operator declared. So after the user enters in the first number, the second number, and the operator, we use a switch statement. So for our next step, we use switch statements. Before we do that, we need to review what they are. The switch statement is a multi-way branch statement. In simple words, the Java switch statement executes one statement from multiple conditions. It's like an if-else ladder statement. It provides an easy way to dispatch execution, different parts of code based on the value of the expression. Basically, the expression can be a byte, short, char, and int primitive data type. So those are primitive data types that the expression can be. It tests the equality of the variables against multiple values. So see an example of switch statements as we learn it. Now William will explain how we use switch statements on the calculator. Yeah, sorry about the switching for screen shares.
Alright. Can you guys see my screen?
Yeah.
Alright, thanks. Okay. So, as Joseph was saying, now that we have initialized all of our variables and laid the foundation for the user inputs, we can work on creating the switch statement. This will receive the operator variable, and depending on what it is, it will choose a certain case. Like, you'll see what it is. So just follow along with me for now. Okay, so now we've created our complete switch statement for addition, subtraction, multiplication, and division. As you can see here, when the user will put the operator character plus, it will tell the program to add num1 and num2. Same thing with if it says subtract, then it'll subtract the two numbers, multiply, and so on and so forth. Then we actually needed to print out the answer, because what use of it is finding the answer if we can't see it. So we're going to want to print it out. And
Sure.
now, sorry.
One quick note I'd like to make is I don't think we taught this in the last meeting, but what William just did with the print statement there is something called concatenation, where it's basically just, you guys might know this from previous computer science classes and whatnot, it's basically where it's just adding all the values and putting it into one string, if you will, so you can print it out.
Yeah. So now, we should have finished our calculator. So let's just save it once to make sure that we don't have any errors besides the scanned object, which will stay forever like that. Now let's make sure you have your console open once you do this. So you're going to click this button to run the program to make sure it works. Please enter your first number. I'll just say 5, second number 2, plus 5 plus 2 equals 7. So yeah, the calculator now works, and now you can test it for all of the other operations. So I can go 5, 2, and minus, it'll do 3. Do it again for multiplication, and yeah. So it's safe to say that this program works for now. But if you want another challenge, you could try adding an option for exponents in your calculator. Does anybody know how to add an exponent to the calculator, or have any ideas of how we're going to do that?
Yeah.
Ray, can you mute your mic? It's picking up all the background noise. Thanks.
Okay. You would use the math.pow.
Yeah. Nice. Yeah, that's what you need to do. But before we use the math.pow function, we would need to import another Java asset. This Java asset will be java.lang.math. Now we're going to want to create another case in our switch statement for that. I'll just use this because that's what you use in some calculators. Answer equals math.pow num1 num2, and make sure to include the break. Let me save it. I still don't have any errors over there. Let me look at my console again, and then let me run it. Please enter my first number. Let's see, 6. Second number 2. Let's find 6 to the power 2. 36. Now just for good measure, I want to test it out again. Let's do 4 to the power of 4. And it's 256. So yeah, this is a basic, simple calculator that you just made with Java.
Yeah, so, William, can you stay on that screen for a second?
What?
Yeah, could you stay on the screen for a second? So, I have one question for all the members of the club and everyone here. Do you guys know why we used integer for num1 and num2, but a double for our answer? Any idea? And feel free to unmute and why.
Well, I guess like if you were dividing numbers, you'd probably want it to be a double instead of an integer, and also when you're doing the exponent and you're doing math.pow, that has to be a double. So I guess it'd be better if you just did that.
Yeah, that's right. You got the point. Because when you're dividing, so anyone know what would happen if it was an integer? I think we covered this last meeting, but if we had an integer answer, and we divided, like let's say 5 divided by 2, the answer was an integer, then what would happen? Anyone know?
Would like round up or down to an integer.
Yeah, so it's called truncating. So 5 divided by 2, even though we all know it's 2.5, it truncate down to 2. This answers the integer in the form of 2. But yeah, you got the idea. Okay, so now moving on to arrays. Here, I'll start sharing my screen. Okay, so can anyone see my screen and hear me properly?
Yeah, I can see your screen.
That's perfect. Now we'll move on to arrays. This we actually wanted to cover last meeting, but that's completely fine. So we'll move on to arrays. So yeah, let Sahil go ahead and explain Java arrays.
Alright. So arrays holds a list of values with the same data type. In order to create an array, you have to first have the data type and then have 2 square brackets, the array name equals, and then all your array elements. For example, if you want to make a string array called fruits, you'd have string, square brackets, fruits equals, and then the curly brackets, and then you'd have each element in the fruits category. So apple, banana, orange, and grape. Since it's a string, you always have to keep in quotation marks as well. Yeah. So some array operations you can use is finding the length of an array using array name.length. You can print a single element of the array, which is the array name, and then you have your brackets and to your index. And one thing to make note of for index, it always starts at 0, so your first element would be 0, not 1. And a simple program to print all your elements is to have a for loop and then have it print the variable setup.
So yeah, so how that works is you have for loop and then you initialize I as a variable, set that equal to 0, the array is equal to 0, and then as long as it's less than the length of the array, you keep incrementing I, so that way, when I is 0, you print out the first element of the array, and then at the end of the loop, I would go up to 1, so you can get the second element, 2, etc. until the array is fully printed out.
Alright, so some sorting algorithms you can use with arrays. So first, what are sorting algorithms? So they're in the name. You use them to sort algorithms in either descending or ascending order. There are many different types, and each one have their most benefits and drawbacks. And each sorting algorithm has their own time complexity, which is usually the best way to determine how good a sorting algorithm is. We'll talk more about that in the later. So another feature of arrays is having 2D arrays. So 2D arrays are basically an array of arrays, and they have both rows and columns. So for example, we have a number array and has an integer value, and to show it's a 2D array, you have to have 2 square brackets and equals and then whatever your element is. So since it's a double 2D array, it'll have an array and then each of those elements are array itself. And basic operations can still be used with 2D arrays, but they have to be modified a bit slightly.
Okay, so now searching through arrays. So there's a sequential or linear search, which is essentially when you're going through one from the start of the search, and you just check if that element is what the element you are looking for. And this search is one at a time. It's not good for large data sets because of the time complexity. What we mentioned before is time complexity is how efficient running an algorithm. So for a large data set, this might not be the most efficient way to search through an array because we're literally looking through every element. And I can show the code in Java for it. I'll just take me a second to open up my Java program. Different line. So a linear search right here to work is my class linear search, and inside the main method, what we have is I have an array, my array, and it's getting set to. I just put a bunch of random values in. The number we want is number 10. So as you can see, that's the 0, 1, 2, 3, 4, 5. It's the fifth element in the array. It starts at 0. So what we're doing here is we have a for loop. This allows us to iterate through the array, and the time is give if condition. So if we find the num that we want, then we'll just do some concatenation and printing num wanted is found. And then if else, nothing happens, we'll just go on, keep repeating. So if you guys want to see this work, right here. So it says 10 is found. Yeah, I think you guys can see it better like this. And then if we changed it maybe to 5, compile it again, 5 is found. Yeah, that's how a linear search works. Back to here, a binary search, on the other hand, is basically a divide and conquer method. So if you guys ever are like looking for a word in a dictionary, how would you guys look for it? Would you look starting at A? So let's say you have a word starting with, let's say you have the word search, right? So you wouldn't look at every word that starts with the letter A, and then every word that starts with the letter B, and the letter C, letter D. You wouldn't do that. You just maybe flip to the middle of the alphabet, and then find, okay, let's say middle of the alphabet, I don't know where it is, let's say it's S. Then you do, okay, it's S right there. So then you look for E. So then you flip a couple pages, and let's say maybe you find the word soft. So that's SO, but SE is going to be before that, so then you know, just flip back. Binary search works the same way. So let's say we're looking for a number right here in this list. Search for 23. Right, so go search in the middle, in the fourth one, 16. So it's not going to be six. It's not going to be in this half. It's going to be in this higher half. So you look in the middle of that, 56. It's not. It's less than 56. Right, 23 is less than 56. It's going to be to the left of that, or to the right of 16. And then you look for both of these. It's 23. And now the thing about binary search is it's more efficient than a sequential or linear search. But as you can tell here, it has to be ordered. You have to be sorted. So sequential, it doesn't matter what order your list is in, but in binary it has to be ordered, like just like a dictionary is ordered from A to Z. Binary has to be ordered with like ascending or descending, some type of order. And I can show you guys the binary search code as well. We'll open it up right here. Binary search. It's just binary search. It's accepting an array and an integer for right and left. And then this is the code, which tells if you're looking for number 23, and is that to the right or left? That's the code we're seeing right here. And we have if statements to you'll kind of see whether to go to the left or to the right. And scroll down here, we're passing in a random array, obviously sorted. And then we have the array length, and we're looking for 10. So if it's found, we print elements present. If it's not, if the print element is not present. So compile this, and then the element is found at index 3. And 0, 1, 2, 3. Sure, now 10 is at index 3. If we change this to maybe 40 and compile this, then search. Element is found at index 4. Now, if we had something like 50, it's not in the search. So try this, compile, run it, element is not present. That's how we kind of tested that our program is working. We put in values and you can tell it's the element is present or the element is not present. So I'll now pass on to Sahil for a deeper dive into storing algorithms.
I can do the slide, Joseph.
Okay, sure. But
Okay, so a deeper dive into sorting algorithms. So sorting algorithms are used everywhere and for many different reasons. Although they all serve the same purpose, sorting an array of values in increasing or decreasing order, one of the main key concepts in sorting algorithms is time complexity. Time complexity refers to the amount of time a program uses and has a O(n) format. For example, loops would have O(n) time complexity. A loop in loop programs would have O(n) squared time complexity, since for each element of the array being checked, it goes through the entire array. There's another pretty commonly used concept being space complexity, which is pretty similar to time complexity, except that it measures memory instead of runtime.
Alright, so one of the many sorting algorithms existing is the selection sort. So this is how it works. Selection sort works by storing the first value of the list and then comparing with every other value. Once it finds the smallest value, it swaps it and restarts the whole process again. And the only difference is it just starts at the second element instead of the first. So the image on the right depicts it. So it has 20 is the first element. It searches for the smallest number, which in this case is 2. When it finds it, it swaps it and immediately goes to the next element and then restarts this process until the entire element is completely sorted. This is a time complexity of O(n) squared because when it gets to an element, it searches the entire array again, twice for each runtime, making it squared.
yeah, okay. And I have obviously the look for it. It's a selection sort. So how we do it in Java. Sorry about that. Open it up here. And I just want to make a quick note. All these sorting algorithms, they're applicable in all coding languages, but because we're learning Java, that's why I've implemented all of them in Java here. So I'll explain this. We have a class, selection sort, and then we have an array. So we're stepping through each element in the array, and then once we find that, so like Sahil said, we're swapping the smallest one and swapping it to the front, and we're doing that in a loop. So here's your loop where we keep finding the smallest one and then swapping it to the front, and then that way we're kind of reorganizing the array as in real time, basically. Instead of building a new array, we're kind of reorganizing it while we go. So right here we have the data to test the program. So here's your array, right? And we want to sort it in ascending order. Right now it's in descending order. Right now it's not even in order, sorry. It has 20, 12, and 15, 2. So obviously if it was in ascending order, it'd be 2, 10, 12, 15, 20. So we can go ahead and test this program if it works. Yeah. Okay, sorting ascending order 2, 10, 12, 15, 20. So we know the program works. And one other thing I'd like to add is these time complexities, they don't really matter for small data sets. Like this data set only has 5 values, right? So it's not taking up much space in my computer. And it might just take maybe a millisecond more because it's O(n) squared. As to where if we use something like merge sort, which is a better time complexity, we might be saving milliseconds. But as these data sets get bigger and bigger, that's when you start to save crucial time by using like the best efficient program, the best, most efficient sorting algorithm. That being said, this is insertion sort. It's another sorting method.
Alright, so for insertion sort, it starts with 2 elements in order and then checks the next element. And then based on the value of that element, if it's greater than, it'll put it at the right of the second element. And then if it's less than the second element, then it'll put it at the first index. And if it's in the middle, it'll put it in the middle. So for example, in the example shown in the bottom right, you have 5 and 2 where it starts off, and then since 2 is less than 5, it replaces 5 as the first index, and 5 is moved to the next index. And then the next value is 4, so it goes in the middle because it's greater than 2 and less than 4, and just continues this process for each value in the array.
So now, I'll show the code for that. So I have insertion sort right here. The editor. So same thing, class insertion sort. We have an array. And then this for loop is used to basically exchange. So you're swapping the first two. That's the first thing you're doing. And then the next value, you're figuring out where you're gonna put it. So when you in that, like, move this to the left. So 5 and 2 here, swaps 2 to the front, and then you have 2 5s. This type is organized technically. 2 5, and you find the next value is 4. You see, okay, you have to put that in the middle. 2 4 5, so value 6. So it's a loop, and our for loop for that is right here, where we're stepping to the array with integer step. In this case, not I. We're stepping to the array, and every time it finds a number in front that's to the right of it, so like outside the you put it back in. So that's what this while statement is doing right here. And here, obviously we have a data set. So then we'll go ahead and test this. So we have 9, 5, 1, 4, 3. We're sorting it in ascending order again. It would be 1, 3, 4, 5, 9. So just compile it. And then this would be insertion. So yeah, 1, 3, 4, 5, 9. Definitely make code work. And yeah, that's insertion sort. Now pass it to William to bubble sort.
Alright, so bubble sort compares the first two elements and sorts them, and keeps on doing this same process over and over until it works. So in the example on the bottom right, so 6 and 2 aren't sorted, so it just sorts them, and then goes to 6 and 8, which already works. So it goes to 8 and 4, and then swaps that, and then goes to 8 and 10, and then that's in order, so that's fine. And then at the end, it'll just keep checking through the entire array, and if it's not greater than the next value in front of it, then it'll swap. Otherwise, it'll stay the same if it's greater. Yeah.
Demonstration for the bubble sort. Okay, so bubble sort, we have our for loop that's going to just allow us to swap, because the reason why all of these time complexities are O of n squared is because for every element in the array, you're going through the array, twice, basically. That's why it's O of n squared. So here's our for loop, and we are checking. So this is the if statement. So check if the left one is greater than the right one, and if it is, we'll switch it. If it's not, we leave it as it is. So that's the code for bubble sort. And now to test it, data array -2, 45, 0, 11, -9, ascending order. So we'll go ahead and compile the code, and then this. So -9, -2, 0, 11, 45. So obviously negative numbers are less than the positive numbers and 0 in the middle. So yeah, that's proof that our bubble sort is working. Now, okay, now we'll move on to recursion. So recursion is part of merge sort. So merge sort is the algorithm that we will learn for sorting. It's actually the very next slide. So, and the reason why merge sort is so effective is because it runs in a n log n complexity. And the reason why it can run like that is because recursion. So we'll touch more on recursion later because it's more of an advanced topic. But from right now, it's where you call a function inside of a function. So you guys might, I mean, you do recursion sometimes. If you guys take like an algebra class, maybe a calculus class, then you're doing recursion, but in math. But this is recursion, but in Java. So here we have, this is the factorial problem from last week, if you guys were here, and we're doing it with recursion because you have a class, hello world, and a public static void string arg, and x equals 10, result equals recursion x. So we're recursively calling this function, which is recursion. We have a recursion function right here. If we have a number, and if it's equal to 0, then we'll return the number, else we'll multiply it by recursion minus 1. So then what would happen is, let's say if we walk into this code, it's finding 10 factorial, and the output for that is right here. So we have the result. So we're trying to find the result, right? And we walk into the code. So let's say int 10 would go right here, and then we make number equal to 1, and x is equal to 10. If x is equal to 0, we return number, because that's when you know we're done multiplying by every, so if you're doing 10 factorial, if x is equal to 0, that's how we know we've done multiplying by 9, 8, 7, 6, 5, 4, 3, 2, 1. Else, we're doing number equals x, which is 10, times recursion, which is 10 minus 1. So 10 times 9. And then we return it and store that value here. So then 10 times 9 is 90. And then that go back up here. And then 9, and we go else 9 times 8. No, sorry, 90 times 8. And whatever that is, times 7, times 6, times 4, 5, 4, 3, 2, 1, until x is equal to 0. And that's when we return num. So here we have a 10 factorial is 3628800. Big number. Okay, so now since we understand the recursion, that's when a function is calling itself, now we can explain merge sort. So generally in computer science, when you're talking about sorting array, most people would go to merge sort because it's the most efficient way to do it. And also, no matter how the array is previously, it always runs in the time complexity of O of n log n. So as you can see in the earlier sorts, like selection sort, it run in O of n squared, which is not the best. And insertion sort, it run in the time complexity would actually vary on how the array is previously sorted. And in bubble sort, it would again vary on how the array is previously sorted. So that's not, we have an inconsistent way of sorting the array, so we don't know how much time it's going to take. And that can be really problematic, maybe not for personal use, but in the professional world, if you don't know how much, if you can't get it approximate on how much time it takes for the array to be fully sorted, that's what we want, right? So this merge sort has it has consistent time complexity of n log n. So, and it's also the most complex sorting algorithm. So how it would work is, I can take it to the next slide. So, a bit of a blurry picture here, there is it. So let's say you have an array here, uncoded, obviously 6, 5, 2, 10, 9, 1. So how you're doing it is you're breaking it up into 6, 5, 12, and then 10, 9, 1. And then this would break up into 6, and then 5, and 12. And then you keep breaking them up, and then switching them. So once 5 and 12, you reorder them. So you have 5, 12 right here, so it's like 5, 12. So here, if it's, say, 9 and 1, we break them up and then put them back in order. So this is 1 and 9. And then put 10 and 1 and 9 back in order. 6, 5, 12 back in order. And then what we've done is essentially just broke the list apart and then rebuilt it back in order. And the recursion part of this is because generally when you're coding recursion, when you're coding merge sort, you have a function that is breaking this apart. So function is breaking it apart here, and calls that same function again to break it apart here and here, breaks it apart here, and then it builds it back up together. So now I will show you the code for merge sort, and it will be a bit complex. But try to try to understand what it is. If you have any questions, just feel free to ask. Okay, so we have our arrays here, and this is a public class merge. So as you can see, it's a pretty long algorithm we have. So to explain it in simple terms, we have our list of numbers, right? We're using the array list. We haven't learned it yet, but it's similar to an array. So, and it does the same purpose for our use right here. The 2, 7, 1, 20, 300, 20. So obviously that's not sorted. And we even have repeat 20. And what we're doing here is we are getting this array list and breaking it up into the left side and the right side. The left side is going to equal a new array list, and the right side is going to equal a new array list. So, and just be a loop. So as long as the array list is greater than at least 1, because you can't have an array of 0 elements, right? So as long as the array list has at least 1 element in it, we are going to recursively break it up. So the recursion part of this is right here. Left equals merge sort. So we're calling the function merge sort inside of inside of the function. And then it'll take them from the left and merge sort right. So what we're doing is as long as lowest you can have elements of right here 6 and 10 and 9 and 1, you can have a list of 1. You can't have a list of 0. So as long as our list is at least 1, our array is at least 1, that's what we're saying here. It's greater than 0, so it has to be at least 1. Then we're going to recursively keep breaking apart our array list. And then this part right here is when we're building it back up. So the left is empty and the right is empty. If the left one is smaller than the right one, then we would add it, and then or we remove it. So add, remove, while left is empty, add, yeah, okay. So this is building it back up, and what the code is saying here is while these while statements right here, this whole function private is building the array list back up. And these while statements, what they're doing is they're obviously in a loop, that's why it's while loop. They are putting it back together. So once we break it apart and get to 6, 5, 12, 10, 9, 1, all individual elements, that is the end of these two functions. This function starts, it starts building back up, right? Like I said. So how it works is these while loops, they are all for checking, because like whenever you're sorting anything, you're always checking 2 elements. So that's where you're checking the 5 and 12, 5, 6, and 12. Okay, 5, 6, and 12, 6 in the middle. And that's just figuring out that it's in the middle. It's just 2, what do you call it, compare statements. So 5, 6, 12. And then the other side, the right side of it, is 10, 1, 9. It would be 1, 9, 10. And you compared it, and then you compare this and this, and you get that final array that's sorted with merge sort. So, do anyone have any questions with merge sort? No questions? Okay. So, that's pretty much the whole meeting. I just ended a little bit early today. Does anyone have any questions with merge sort, bubble sort, insertion sort? Okay. So, I'll go ahead and stop sharing. And so, we've pretty much covered the basics of Java and done a couple exercises in it. So we were thinking, are there any new experiments or new exercises or maybe projects you guys want to start on? If we've covered the basics for most of them by now, feel free to unmute and say if you guys are interested in maybe, because Java can be used for practical things like building calculators and sorting like we did, but it could also be used for more, like, let's say, cooler projects like building games and websites. So if you guys are interested in that, feel free to unmute and say what you guys would be interested in. Any ideas? Okay, that's fine. If you guys do think of any ideas, feel free to put them in the general chat. But I guess that's pretty much the meeting for today. William, Sahil, do you guys have anything to add?
I think this was a pretty good meeting overall, and thank you guys for joining the meeting.
Yeah, thanks everyone for joining. And then sorry on the delay I had. I had microphone issues. Yeah, you guys just put it.
Bye, guys.
Bye, guys.
Bye.